Hello everyone. I hope you are doing good. Now we are going to discuss memory and programmable logic devices. So here we'll go a little fast so that we have quick revision about this one. So first thing is what is the memory? So memory is the device that is going to store the binary information, and here you can perform the read and write operation with the help of address. So whenever you talk about the memory means it consists of the various cells where if you want to store the information or if you want to retrieve the information, so that particular address is required. So always selection of the particular address is important to choose the particular cell. Then we have various types of the memory. So we have two types of the memory. One is the RAM and another is the ROM, which is called as random access memory. Another is the read only memory. So random access memory is the volatile memory and read only memory is the non-volatile memory. In case of RAM, we can perform the read and write operation both, whereas in case of ROM, only we can perform the read operation. So in the case of write information, first we have to choose the particular cell with the help of address where we are going to store the information. And in case of read operation, directly we are going to give the address from where we are going to obtain the information. So in this, both address bus and data bus is going to play the role. So again, we have, if you see about the random access memory, so here we are going to store the information in the memory that is in the form of word, and each word can have 1 byte of information. It can have 2 byte of information. 1 byte is equal to 8 bits, and 2 bytes will be 16 bits. So if you talk about any memory, so in that memory, if you have a size of, suppose we are talking about 64 cross 8 memory size. So this 64 can be written as to the power 6 cross 8. So that means to locate or to give assign address to each cell, we require the address with the 6 bits. And here, word size is what? 8 bits. So that is the 1 byte. So here, this is the symbolic representation where we have memory units in which we can store to the power k words. So that means we have this much location of the memory, and each address will have 8 bits, and here each word contains the small n bits. So that is the representation. So whenever we are trying to address the memory, that is address always will start with 0 and it will go to the power k minus 1. Suppose, for example, if you are talking about, for example, address having 4 bits. So that 4 bits means we have total combinations, that is the total 16 combinations are there. So that 16 combination will start from the 0, it will go up to 50. So counting will start always from the 0. So when we have different devices that having different memory capacity, like if you have kilobytes, so kilo is to the power 10 here, so that will be equal to this 1024. And we have mega, that is to the power 20, giga to the power 30. So if you have any memory or RAM, suppose for example in the mobile we have 4 GB of RAM, so that capacity is to the power 2 is the 4 and GB is the to the power 30. Totally it can store the to the power 32 bytes. So that is the maximum capacity of the particular memory. So these are the examples how we can locate the particular cell in the memory. So when we have to perform the read and write operation. So for the write operation, what are the requirements are there? So first step is here that first we have to choose the particular cell with the help of particular address. So that address is given to the address bus. Then we are going to locate the information what we are going to store, that is given to the data bus. And further, now write will be enabled, then only write operation will be performed. Whereas in case of read, since your data is not required, we are going to retrieve the information. So only address will be given to the particular address bus. After that, we are going to get the output. That output is going to come to the data bus. So that we have to see how we are performing right hand. So here we have timing waveforms. So that also can be useful. So that time period of this timing waveform depend upon the processors. So as per processor, what is the frequency of the processor, what is the time period, as well as when we are going to perform the write operation, it is going to take how many cycles. So that depends upon the processor. So in this case, we are trying to perform the write operation in the almost 3 cycles. So each time period is of 20 nanoseconds. So we have almost 50 nanoseconds. So before that 50 nanoseconds, all this write operations should be performed, or whenever we are going to perform the read operation, that also should be performed. That is represented here in the diagram. So here data will be available for the particular interval of time only. So here main important thing is types of RAM. So different types of the questions for the university purpose they're asking. Explain or describe about the various types of the RAM and ROM. So here RAM already we have seen that it is the random access memory and it is the volatile type of the memory. So it has two types. One is the static, another is the dynamic. So static RAM means it has internal latch, and latch is what? It is the level trigger device that store one bit of information. So when it achieves the particular level, it will have same information until input is not going to change. So here it's easy to use and requires the shorter read and write cycle. So here we can have this is the word line, and here we have bit line, and finally this is represented with the help of one latch where we are going to represent the single cell of the static RAM. Then another is we have dynamic RAM. So in case of dynamic RAM, we have a concept of the capacitors. So that capacitor charging and discharging is going to decide the functioning of the dynamic RAM. So regularly we used to refresh the device so that capacitor will be charged. So when capacitor is going to charge, it has a storage as the one. When it is going to discharge, we have a storage as the 0. So that is the here we have concept of MOS transistors. That MOS is the metal oxide semiconductor. So nowadays, due to the ferroelectric materials, that is the new technology. So RAM is also going towards the non-volatile memory. And in the system, we are using the various types of the RAM. That is, we have SD-RAM, then we have SDRAM is the synchronous DRAM. Then we have SDR is the single data rate, so where processor will be little slow. And when we have DDR, that is the double data rate. So we have different versions of the DDR. Another very important topic is the different types of the ROM. So ROM, here only we can perform the read operation, and it is the non-volatile type of the memory. So how we are going to design the ROM? So for that, if we are trying to design the ROM of the size to the power k cross n. So here we have required the address that should have k bits, and here n is the number of the outputs that is going to give the data information. So this ROM will be designed with the help of we are going to take the decoder. Later we'll discuss more detail about this. So when we have size of to the power k cross n, so we'll see later that we have a decoder of size k cross to the power k. So where k will be the number of inputs to the decoder, and to the power k will be the number of outputs to the decoder. So slowly we'll have multiple logic gates. So for that purpose, in place of conventional symbol, we are going to use the array logic symbol. So here example is taken in which we are going to design the ROM with the decoder of size 5 cross 32. So here 5 inputs are there. That means address having 5 bits here. So total capacity means cell location in the memory is to the power 5. And here we have 0 to 31 output of the decoders, and each decoder's output is connected here. So since here memory capacity, we see that word size is of 8 bits. So here we have 8 n gates. Sorry, here we have n 8 OR gates. So this OR gate is connected here to the output of the decoder. So we can have 8 bits over here. Now one example is taken here where user having requirement to design the combinational circuit by using ROM, in which they have input with 3 bits and output is equal to the square of the input number. So with the help of 3 bits, we have total combination that is 0 to 7. So when you will square this, again it will go from the 0 to 49. So this 49 is represented finally with the help of 1, 0, 0, 0, 1. So this is the table for that, truth table. Inputs and corresponding outputs are there. So here, when we go for the K map of this, each and every output, here B0 to B6, total we have here 7 outputs. So in the K map, you should see here, with the help of truth table, so we can realize here for different values when we are going to represent here. So we'll see that in this B0, what is similarity? B0 is same as the A0, and B1, all bits are 0 only. That's why we are able to do this. So here if you see that B0 and B1 is the bypass, it's not included in the ROM. So ROM is designed here with the help of 8x4 size. Since 4 outputs only we are going to obtain from here ROM, and these two are direct. So finally we have ROM truth table here. So generally they used to ask about various types of the ROM. So we have 4 types of the ROM. First one is the mask ROM. So in the mask ROM, during the manufacturing, path is provided as per the user requirements to produce the connection for the ones and zeros. So it is more costly, but when we are going to manufacture the large numbers of the mask ROM, that becomes the economical. Second type is the PROM, that is the programmable ROM. So again, this is the completely hardware based. So when here fuse is intact, means it's going to give all ones that being stored. And when fuse is blown, this blown means it is when we are going to supply the high voltage, so then fuse will burn. So that is going to represent the zero state. So it is completely hardware based and it is the irreversible. Third type is the EPROM. EPROM is the erasable PROM. So here we can erase the information by the help of expert who is going to apply the ultraviolet light for the limited time of duration. So after erase, again it will come back to the initial state. So it is the can be reprogrammed again and again. But during working condition, we can't do the reprogramming of this one, or data cannot be erased. Whereas in case of double EPROM, that also can be called as E square PROM. So it is the electrically erasable PROM where in place of UV light, we are going to use the electrical signal. So now here, this device doesn't require removal from the socket during working condition. Also, we can erase the information. And later we'll see that how we can design the PROM. So to design the PROM, that we have first stage, that is the fixed end array, or we can use the decoder, and second stage is the programmable or array. So we have much discussion again about this in another video also. And another very important topic is programmable logic array. In case of programmable logic array, here it is much similar to the PROM, but what is the difference here, that full decoding is not available here. So decoder is replaced by the programmable and array gates here. And here second section is also programmable or array. So first is the programmable and array and second is the programmable or array. So now here we have, so this when we have AND array means it's going to represent the product terms and this OR array is going to represent the sum of product terms. So this is the use of OR gates here. So now here we have taken one example in which we have 3 inputs and 2 outputs. So for the examination point of view, function will be given. So generally for the function, mean terms will be given from that function. Given mean terms, we have to do the K-map, and from the K-map, we are going to obtain the Boolean function. So sometimes they are going to ask that design this PLA with the help of 4 product terms, with the help of 3 product terms. So in that case, when we are going to take the K-map, then we have to see that both K-maps would have maximum overlap for mean terms, either by using the complement or it is directly available means it's okay. Otherwise, we have to take the complement of one function so that we have limited number of the product terms as per given specification. So here, in this case, we have 4 unique product terms. One is the AB dash, another is the AC, third one is the BC, and fourth one is the A dash, B, C dash. So now since we have 4 unique product terms, so we require 4 AND gates here. So input to the AND gates is given with the help of buffer. So where we have inverted and non-inverted output. This is the A dash, this one is the A. Similarly here, this is the B dash, this one is the B. Again here C dash, and this one is the C. So since here we have a programmable and array. So we are using the symbol of the logic array. So this first one is going to represent the AB dash. So this cross is connected here where we have A, and this is the connected where we have B dash. So this cross going to represent here that fuse is intact, whereas this plus symbol where we are not applying the cross, that shows that fuse is blown. So like this, we are going to give the connection to each AND gates. So corresponding literals are connected here on this logic array line with the help of cross. So if sometimes maybe we have 3 input AND gates or we have 4 input AND gates. So if you are going to give here, like in this case, we have given only 2 inputs here, A and B dash. So remaining 2 ports are assumed that it has input as the 1 in case of AND gate. Since in case of AND gate, if any input is 0, output will be 0. So that's why all inputs would be high. So now here again, second part, this is the about this programmable AND array, and second part we have programmable OR array. So since we have 2 functions here, one function is F1, another is F2. So we require 2 OR gates here. So again, it is programmable. So same logic array concept we have used. So one going to represent the function F1, another going to represent the function F2. So that connection is done here with the help of OR gates. Now since one function is with complement, another function is without complement, so we are going to use the XOR gate. Suppose we are able to satisfy the condition where function is both functions are without complement, then we don't require this XOR gate. Here itself we are able to get the desired output. But here we have one function with complement. So the function which is with complement, that will connected with 1, and without complement function is connected with 0. Since in case of XOR, X XOR 0 is the X, and X XOR 1 is what? X dash. So this logic is used here to obtain the output as per the requirements. Now the same thing we can represent in the form of tables also. So this we have 4 unique product terms that is written here. Then input, if input is available, if it is without complement, we'll write 1. With complement, we are writing 0. If it is particular literal is unavailable, So we are doing the underscore. Similarly, in case of function, if you see that if particular term is available, we are writing 1. If that term is absent, we are writing the underscore or dash. Similar in case of function F2. So function F2 is here. What we have implemented, we have taken the concept of complement. So we are writing C here, and in case of F1, it is without complement. So using the true value. Now, if in case of PLA itself, in place of given Boolean function directly, we have mean terms are given, then we are going to obtain the K map. So if you see in this case, once we'll apply the original mean terms, whatever things are given, then we are observing that it's not going to overlap or number of product terms are not being obtained as per the given situation. So in that case, we have taken complement of this first function F1. So this complement means which mean terms are not given, for that we have assigned the value 0 and we have formed the required combination. On the basis of that, we have obtained the value of F1 is like this, the F2. So again, if you'll observe here, so we have 4 unique terms are there. So 4 unique product terms we are going to represent. So same in the similar way, we can use the block diagram as well as to for the logic implementation, we have to use the programmable end array and programmable array. So last one here we are going to see about, that is the programmable array logic. So in the programmable array logic, what is the difference here? That this first section is the programmable end array, whereas the second one is the fixed array. It is not programmable here. So in case of PAL, this product term, what we are going to obtain, that will not be shared with another functions. So how many inputs are there, how many product terms are there for the particular function, even it is the similar, that again we have to provide the end get for the that product term also. And sometimes to make it look symmetricity, if suppose for example function F1 having 2 product terms and we have function F2 having 3 product terms, so then we can add here one extra AND gate to the F1. But this AND gate will be without connection. So like here we have functions are given W, so it is 4 variables. So it is 4 variables means we require the K map which will have 16 boxes. So on the basis of K map, again we have to find the simplified Boolean function. So that simplified Boolean functions are like this. So this can be realized with the help of K map. So sometimes particular function is already function of another function. Like here, if you see that Z, so Z having the combination what we have for the W, that is A B C dash plus A dash B dash C dash D dash. That is already available here in case of Z also. So in place of that, we have written the W. Now those things can be realized here, like we have done in case of PLA. Similar realization is here. So now if you see that this third one, we are using the false AND gate, so that everywhere it is the dash. Similarly here, sixth one, we are going to use the false AND gate, so it is everywhere dash. Since here, this maximum number of product terms here we have 3. So for the each function, we are going to assign the 3 AND gates. So for the first one extra AND gate, for the second also one extra AND gate. So those AND gates are the false AND gate here. So now same thing we are going to see in the form of the logic diagram. So for the each function, since we have 3 AND gates, so these 3 AND gates are given here, and corresponding what are the literals are there, that is marked with cross. If cross is not there, means that fuse is blown. So this AND gate and these 2 AND gates are given the connection. Third product term is not there, so that is the mark here as cross. And here if you see that what is the common product terms also, for that also we need to use a separate AND gate. And output of AND gates are given to the OR gate. So here in general we have 4 variables input, but since in the function Z we have W also as a function. So W is also included here as the input. So again, buffer connection is here, and this W what we got output, that is also connected here with the buffer to obtain the W and W dash. So this is the first one is for the W, second is for the X. So again, here we have two product terms. That product term is connected. So in case of X, if you see that one is A, so that A is connected here. Another is the B, that is connected, then C, then we have D, so BCD. So that connection are given. So two product terms, so both connections are given here. Third one is the false one. Similarly, in case of function Y, we have three terms are here, A dash B plus CD plus B dash D dash. Those again connected with the help of three AND gates. These connections are given here, and finally it is connected with the OR gate. And fourth one, again here we have including W, we have three terms here. So that's why we are using the three AND gates. So this is for the W, this is for the another values and another values. So W is what that is what here W plus A C dash D dash plus A dash B dash C dash D. So those connections are given here. So this cross represents the presence of particular literals. Without cross, what is the plus? That is shown the fuse is blown, and this cross shows that fuse is. So this is the discussion about the chapter that is called as memory and programmable logic devices. So here important question is for the examination point of view, we have different types of the RAM, different types of the ROM, then design the particular Boolean function by using PROM, by using PLA, by using PAL. In case of PROM, first section we can use the fixed AND array or we can use the decoder, whereas the second part we have programmable OR array. Whereas in case of PLA, both are programmable. AND array is also programmable, OR array is also programmable. In case of PAL, we have AND array is programmable, OR array is fixed one, and here product terms cannot be shared with another function. Thank you very much. So go through this. I hope it will be useful for you. Thank you once again.